Hi guys. Today we're going to talk about Pythagorean theorem, but we are also talking about Pythagorean theorem word problems. So let's think back to Pythagorean theorem. When we solved problems where we had to find a missing side length, we always talked about right triangles. So let's jot ourselves a little note up here that Pythagorean theorem, remember, has to deal with right triangles. So when we draw pictures for these Pythagorean theorem word problems, we always have to have a right triangle somewhere in our picture. So let's take a look at what number 1 says. Number 1 says the bottom of a ladder is placed 6 feet from a wall. If the top of the ladder rests 8 feet up on the wall, how long is the ladder? You must draw a picture to solve. So when you're dealing with a ladder, we know we're going to have a ground, and this tells us we're going to have a wall. So here's what I'm going to do. I'm going to draw the ground, and I'm going to draw a wall. All right. So I'm going to label that this is the ground, and here is my wall. All right, so hopefully you can kind of see how we could maybe make a right triangle out of this. So we know we want to put a ladder 6 feet from the wall. Well, when you put a ladder against a wall, you're not going to put it right up against the wall, because if you did when you climbed up, you would probably fall back. So when you put a ladder on a wall, you usually want it tilted up against the wall. So do you see how now I have a right triangle? I have part of the ground, I have the wall, and then I have my ladder at a slant. So here's what I'm going to do. I'm going to draw my ladder. All right, so now look, I'm going to draw. You don't have to make it look like a ladder, but I'm just going to do that because it's a word problem, just so that we can see what it looks like. This is my ladder. All right. So now let's label the dimensions that they gave us. They told us that the bottom of the ladder, so here's the bottom of the ladder, it's 6 feet from the wall. So this is 6 feet. All right, 6 feet. It's saying the top of the ladder rests 8 feet up on the wall. It's not saying the ladder is 8 feet, it's saying it's up 8 feet on the wall. So this length is going to be 8 feet. That's how far it is up on the wall. We want to figure out how long this ladder is. We don't know how long the ladder is. When you don't know how long something is, what do we usually call that? We usually call that x. So, can everyone see my right triangle here? This is where my right triangle would be. And this is where my right angle would go. So if that's my right angle, the side across from the right angle we always call the hypotenuse. So, let's recall. Pythagorean theorem is a squared plus b squared equals c squared. C squared is always the hypotenuse. All right, so this is calculator time. We want to make sure we have our calculators out and ready to go. So, let's plug in some information here. 6 and 8. Those can go in for A and B. So 6 squared plus 8 squared equals our hypotenuse. Do we know what that is? We don't, so that's where my x goes. All right, so let's take a look. 6 squared is 36. 8 squared is 64. And that equals x squared. Let's add our 36 and our 64. And we get 100. Now the ladder is not 100 feet. Remember when we do Pythagorean theorem, what do we have to do to get rid of that x squared? We have to take the square root. That cancels out that square. So when we do the square root of 100, we get 10. So x equals 10, and I'm going to leave a little space so we can put feet. The ladder is 10 feet long. All right, let's do a second one. Let's read the question first. Brett's TV screen is 44 inches wide. If the diagonal measures 50 inches, what is the height of Brett's TV? You must draw a picture. So let's think about what a TV screen looks like. What shape is a TV screen? TV screens are rectangular. So let us draw a rectangle for our TV. So we've got Brett's TV right there. All right. His TV screen is 44 inches wide. All right. So when we talk about length and width, it really doesn't matter where we put our length and our width. But what it does matter, it says if the diagonal measures 50 inches. So they're talking about this length right here, the diagonal. This is 50 inches. This is our diagonal. They want to know what the height of the TV is. So if we don't know what the height is, we're going to call that x. That's the height. The TV screen is 44 inches wide. So 44 inches can go right here for how wide it is. So I hope you can see that if I trace over 1/2 of this TV, I have my right triangle. And my right angle would go in the corner. And if that's the right angle, the side across from it is my hypotenuse. That's my C value. So when you do Pythagorean theorem word problems, you have to draw a picture and you have to label, and you always want to make sure in your picture you have a right triangle somewhere. So a squared plus b squared equals c squared. This is my a and my b, my legs. So we can do x squared plus 44 squared equals, and that's my hypotenuse, 50 squared. So definitely need my calculator for this. I don't know what those numbers are when we square them in my head. So x squared plus, so 44 squared is 1,936 equals 50 squared is 2,500. All right, let's subtract our 1936 from both sides. So we have 2,500 minus 1936, and we get 564 equals x squared. So in the last problem before, to undo our square root, our square, we have to take the square root. So x equals, so let's take the square root of 564. We get 23.7, and we're talking inches. Inches. So let's write down that the TV height equals 23.7 inches. That's how tall the TV is. So I want to quickly look at what you're going to have to do for your work on your own. There are going to be 3 regular Pythagorean theorem problems. So it says find the missing side length, use Pythagorean theorem. So let's fill that in. A squared plus b squared equals c squared. Remember that c is always the hypotenuse, the side across from the right angle. And then what you're going to do, I kind of have a problem here that's one of the word problems, and the picture is drawn for you. You can read the problem and draw your own picture if that makes it a little bit more clear for you.